Hello and welcome to my kitchen floor. Today we are going to be measuring the coefficient of kinetic friction of my kitchen table. Now I have it propped up here on paint cans, which gives it an angle of almost exactly 75 degrees that way, which means it's 25 degrees. It's 15, 90 minus 75 is 15 and not 25, thank you. And for those of you who don't drown yourselves in physics every day, the coefficient of kinetic friction is a way to quantify how much friction is between two objects. The higher the number, the more friction there is between those two objects. Let's test it. Perfect. So here I've marked off a length of 50 centimeters on my table, and I'm using metric instead of imperial because it's just easier to do, honestly, with calculations and stuff. Okay, and so what we're gonna do to measure it is we're going to start out our object at the beginning, and we're going to measure the time it takes to fall to that second purple mark. And then once we have that time, we're going to put it in this spreadsheet. Okay, so how we're going to measure the time, since I don't feel like doing, like, you know, the normal thing and just getting a timer or a stopwatch, I'm going to use the photo burst option on my iPad here that I'm filming on, which takes a photo at 10 frames per second. And then I'm going to look back at the photos, and I am going to find which photo gets the object just past there or right there, and that should give us about 2 decimal places of accuracy for our time. And the cool thing about this is we don't even need to know the mass of our soap container filled with screws. I did the math all over here, nerd stuff, blah, 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 blah. And mass doesn't even come into our mu equation, our kinetic friction equation. But we do need the length from point A to point B, and the angle, and then the time. Since we're going to keep the length and the angle consistent, we're just going to measure the time. And that is how we are going to compute the friction. We measured the soap dispenser falling 15 times. And we averaged that right here. Over here, we did a very complicated something or other here. And we got our mu sub k. And now, since there might be some error in there, some starting or stopping earlier, some human stuff in there, we did something called the standard deviation. And the standard deviation pretty much measures how off you're going to be any given time within a reasonable margin of error. And so that's where this complicated thing came in. Ooh, pretty. Lots of letters and numbers. And this is what we got. That's a pretty low standard deviation. Now, we did not have many trials. Also, we only did the first standard deviation, so this is probably not entirely accurate, but I'd say that's pretty good. So the coefficient of static friction, So the coefficient of kinetic friction between my kitchen table and this soap container is 0.103 plus or minus 0.0081. That's pretty neat. And if you also want to figure out the coefficient of kinetic friction of any surface, you don't really need to know all of this mumbo jumbo, because I have put in the description a read-only copy of this spreadsheet. You can put in your numbers here, and it will change them. And you will be able to calculate the kinetic friction of whatever you would like.